Determination of sample size, a review of statistical theory, Chapter 17, Business Research Methods. After studying this chapter, we're going to be able to understand the basic statistical terminology, interpret the frequency distributions, proportion, and measure of central tendency and dispersion, distinguish among population, sample, and sampling distribution, explain the central limit theorem, summarize the use of confidence interval estimates, and discuss major issue in specific sample size. Now, the opening example is about the payment options that have gone high-tech in the last decades, and businesses that sells to consumers need to plan for a wide range of choices beyond traditional cash or checks. So today, spenders are more likely to pay with a debit or credit card through a variety of methods for electronic transfers and for funds. So in order to measure this trend in more details, the researchers at Federal Reserve, they conducted a survey to the depository institutions, banks, savings and loan institutions, and credit unions, asking them to report the number of each time of payment. So when they planned this survey, they designed a sample including the number of institutions to contact, and they used a stratified random sample to be used for each type of institution that would be included. With a response rate from 1,500 institutions that responded, they confirmed the earlier analysis that they showed that the number of checks paid in US is declining, while the number of electronic payments is as well increasing. So by identifying the proper sample size that was required to apply this statistical theory, they try to understand how important statistics is, and we just involve simply learning some specialized language that statisticians are using. So this is why we need statistics in research. Statistics is the language of the researcher, and in these chapters we're going to try to go to understand some of the basic keywords related to research and statistics. So descriptive, here the first one, descriptive and inferential statistic. Technically, descriptive statistic describes basic characteristic and summarizes the data in a straightforward and understandable manner. Another type of statistic is inferential statistics. It used to make inference or to project from a sample to an entire population. So two applications of statistic exist. One is descriptive statistic that describe characteristic of the population or the sample, and then the second one is inferential statistic that used to generalize from a sample to a population. Now, a sample, what is a sample? A sample is a subset or a relatively small portion of the total number of elements in a given population. Sample statistics are measured, computed from sample data. Business researchers, they try to deal with samples, and we based our decisions on the sample. So the primary purpose of inferential statistic is to make a judgment about the population or the total collection of all elements about which a researcher seeks information based then on a subset of a population. And population parameters are measured characteristic of a specific population. There are information about the entire universe of interest, and sample statistics are used to make inferences or guesses about population parameters based on a sample data. And we're going to use usually Greek letters in order to represent these population parameters, like mu or alpha, or for a sample statistics we're going to use English letters like X or S. Now, how we can make data usable? Yeah, so through methods for doing this includes frequency distributions, proportions, measures of central tendency, and measures of dispersion. The first one, frequency distribution, it's one of the most common way to summarize a set of data is to construct a frequency table or a frequency distributions. And this process begins with recording the number of times a particular value of a variable occurs. A similar method of describing the data is to construct a distribution of a relative frequency or a percentage distribution. To develop a frequency distribution of percentages, we need to divide the frequency of each value by the total number of observations and then multiply the results by 100. Probability. Probability is the long-run relative frequency with which an event will occur. Inferential statistics uses the concept of probability distribution, which is conceptually the same as percentage distribution, except that the data are converted into probabilities. And here we have frequencies, the number of people who hold deposit in each range. For example, you have exactly the number and then the total 3,120. When we go in percent, the 3,000 is 100%, and then each one we calculate the percentage. And probability, it's not 100%, the probability is from 0 to 1, and then we have the same probability, because in this example, with the probability distribution of the deposits. Now, another example here, it's about averages. And this example that we have here in the on the slides is about that average pay could mean there's highly paid executive and many low pay employees, and the median may be more informative than the other averages. So when you need an announcement, when you read an announcement in the news that a corporate executive or a business owner that the average pay of the people who work in his or her establishment is so much, the figure may mean something or it may mean nothing. If it's an average, if the average is a median, you can learn something significant from it. Yeah, that half of employees make more than that and half make less. But if it's a mean, you may be getting nothing more revealing than the average of one, I don't know, 500,000 income, the owner, and the salaries of the other workers. Yeah, annual average pay may be 60,000, but it will conceal both that some workers will have 20,000 and the owners is 500,000. So it's a total discrepancy between them. So what do we understand out of what average means? That's why it's so important to understand this and how to use them properly. Now, proportions. When a frequency distribution portrays only a single characteristic in terms of percentage of the total, it defines the proportion of occurrence. So a proportion may be expressed as a percentage, 25%, as a fraction, 1 divided by 4, or a decimal value is 0.25 in this case. So the measures of central tendency. Managers count the number of sales each sales representative is making, or they want to inspect the data in order to find averages, to find the middle area, to find the frequency distribution, or the central tendency. And the central tendency can be measured in 3 ways: the mean, the median, and the mode, each of which has a different meaning. The mean, we all have been exposed to the average that is known as the mean, and the mean is simply the arithmetic average, and it's perhaps the most common measure of the central tendency. More likely by now you already know how to calculate a mean. But again, we have some symbols. Yeah, we have the sum, the mu, and the x are easier to understand the statistics and how we express the mean in mathematical mode. We use the Greek letter sigma. Yeah, this e, the sigma, and then we have here the population mean on the lower left corner of the slide. Yeah, and divided by how many we have. This is the formula. The next one, the median, the next measure of the central tendency is the midpoint of the distribution, or the 50th percentile. The median is the value below which half of the value in the sample fall and above which half of the value fall. So the median is kind of the half of the observations. The mode refers to the most popular fashion. In statistics, the mode is the measure of central tendency that identifies the value that occurs more often. This is the mean, median, and the mode. And here we have the number of sales per day, number of sales, how many we have in total for each. And then based on that one we can do the calculations. Now, measures of dispersion. The mean, median, and mode summarize the central tendency of the frequency distributions. An accurate analysis of data as well requires knowing the tendency of observation to depart from the central tendency. Yeah, what is the spread across the observation? And there are several measures of dispersion. One is the range. The simplest measure of dispersion is the range. It's the distance between the smallest and the largest value in the frequency. And here we have the sales from two products with identical average sales, and here we can see in January 196 I think is the lowest, and then the highest in December 202. So 6 units, the difference between them. The range, product A, it's between 196 and 202 units, so it's 6 units, and then for product B it's 150 and 261. 100, here we have how much, 111 units is the difference between them. So the range does not take into account all the observations, it just tells us about the extreme values of a specific distribution. Now, we do not expect all the observation to be exactly like the mean. We can have a skinny distribution that will lie a short distance from the mean. And here in the product A, an observation that are close together and reasonably close to the mean. And in product B, we have a more spread, a more spread distribution in the other case. Why we use the standard deviation? Why we use the standard deviation? Statisticians have derived several quantitative indexes to reflect the distribution spread or variability, and the standard deviation is perhaps the most valuable index of spread, or the dispersion. Learning about the standard deviation will be easier if we understand other several measures of dispersions. And each of them has certain limitation that the standard deviation does not have. And then the variance. The variance, it's typically to make inference about the population from a sample. So we have a measure that is called the variance, and measures the variability and is the square root of the standard deviation. This is the formula. The standard deviation, on the other hand, while the variance is frequently used in statistics, it has a major drawback. The variance reflects a unit of measurement that has been squared. So if measures of sales in a territory are made in dollars, the mean number will be reflected in dollars, but the variance will be in square dollars. So statisticians often take the square root of the variance, and using a square root of the variance for a distribution called the standard deviation eliminates the drawback of having the measure of dispersion in square units rather than in the original measurement units. So this is about the standard deviation, and we need to think at the original purpose for measures of dispersions. We want to summarize the data from survey research and from other businesses researches, and indexes of central tendencies such as the mean help us interpret the data. But in addition, we wish to calculate a measure of variability that will give us a quantitative index of the dispersion of the distributions. And we have several measures of dispersion that will help arrive at two very adequate means and measuring the dispersion, the variance and then the standard deviation. How we can calculate deviations? Here we have some formulas. I hope that some of them are familiar. But the first one, the average deviation, by calculating the deviation score of each observation value, summing the scores and then dividing by the sample size. The mean absolute deviation by computing the absolute values of the deviation, and then we have the mean absolute deviation. These procedures eliminate the problems of always having a zero score for the deviation measure, and in some mathematical problems make it less valuable than some other measures. The mean square deviations provide another method of eliminating that positive-negative sign problems, and in this case the deviation is squared, which eliminates the negative values in this case. And then variance and standard deviation we've discussed before. Here is an example calculating a standard deviation, how we can calculate it. The normal distribution. One of the most common probability distribution in statistics is the normal distribution, and commonly represented by the normal curve. This mathematical and theoretical distribution describes the expected distribution of sample means and many other chance occurrences. The normal curve is a bell-shaped, and almost all 99% of its values are within plus minus 3 standard deviation from the mean. The standardized normal distribution is a specific normal curve that has several characteristics. And these characteristics are: it's symmetrical about its means, the tail on both sides are equal. The mode identifies the normal curve's highest point, which is also the mean and the medium, and then the vertical line about which is the normal curve is symmetrical. The normal curve has an infinite number of cases. It's a continuous distribution, and the area under the curve has a probability density equal to 1.0. And the standardized normal distribution has a mean of 0 and the standard deviation of 1. The standardized normal distribution is purely theoretical probability distribution, but is the most useful distribution in inferential statistics, and statisticians have spent a great deal of time and effort making it convenient for researchers to find probability of any portion of the area under the standardized normal distributions. All we have to do is just to transform, to convert the data from other observed normal distribution to the standardized normal curve. So the standardized normal distributor is extremely valuable because we can translate or transform any normal variable into a standardized one, from x to z. So computing the standardized value, the z of any measurement expressed in original unit, is simple. Just subtract the mean from the value to be transformed and then divide by the standard deviation, all expressed in standard units. here we have the standardized normal distribution, and here we have as well the standardized value can be computed from flat or peak distribution, resulting in the standardized normal curve. Yeah, so at the top we have a flat distribution, and then at the bottom we have a peaked one that can be converted through standardization in a normal distribution. And this is the standardized distribution curve. Now, related to population distribution, sample distribution, and sampling distribution, before we showed the techniques of statistical inference, and then 3 additional types of distribution we need to define: the population distribution, the sample distribution, and the sampling distribution. When conducting a research project or survey, the researcher's purpose is typically not to describe only the sample of respondents, but to make an inference about the population. And as we defined previously, a population or the universe is the total set of collections or collections of potential units for observation. So the sample is a smaller subset of the population. A frequency distribution of the population element is called a population distribution. And then the mean of standard deviation of the population distribution is represented by the Greek letters mu and rho. And the frequency distribution of a sample is called a sample distribution. The sample mean is designated the x bar, and then the sample standard deviation is the designated s. The concepts of population distributions and sample distributions are relatively simple, but we need to discuss about another distribution, the sampling distribution of the sample mean. The sampling distribution is a theoretical probability distribution that in actual practice will rarely be calculated. But practical business-oriented individuals have sometimes difficulties understanding why the notion of sampling distribution is important. And then what would happen if we draw a large number of samples, 5,000, and each having n elements from a specified population. Assuming that the sample were randomly selected and the sample means could be arranged in a frequency distribution. But because different people or sample units would be selected in the different sample, the sample means would not be exactly equal. So then the shape of the sampling distribution of a considerable importance for statisticians. And if the sample size is sufficiently large, and if the samples are randomly drawn, we know from the central limit theorem that the sampling distribution of mean will be approximately normally distributed. And then we have the sampling distribution. Is a theoretical probability distribution that shows the functional relation between the possible values of some summary characteristics of n cases drawn from a random and the probability, the density associated with each value over all possible sample of size n from a particular population. So the sampling distribution mean is called the expected value of the statistics. The expected value of the mean of the sampling distribution is equal to mu, and the standard deviation of a sampling distribution of x bar is called a standard error of mean, and is approximately equal to, here we see the formula at the bottom, so it's rho divided by radical square roots of n. We now have much of the information we need to understand the concept of statistical inference and to clarify why sampling distribution has the characteristics that we just described. We will discuss on 2 concepts, the standard error of mean and the central limit theorem. The central limit theorem which states that as a sample size n increase, the distribution of the mean x bar of a random sample taken from practically any population approaches a normal distribution. and the central limit theorem works regardless of the shape of the original population of the distribution. So this is finding the mean of the random sample of a sufficiently large size will be approximately normal in form of the mean of the sampling distribution will approach the population mean, and this is very helpful in this case. The next one is the estimation of parameters. Here we need to discuss about point estimate. Our goal in using statistics is to make an estimate about population parameters. And the population mean and the standard deviation are constant, but in most instances of business research they are unknown. So to estimate the population value, we are required to sample. And as we discussed, x bar and s are random variables that will vary from sample to sample with certain probability. It's the sampling distribution. So if the sample mean x, we might use these figures as a point estimate. And the point estimate is the estimate of the population mean in the form of a single value, and it's usually the sample mean. Confidence interval, if we specify a range of numbers of intervals within which the population mean would lie, we can be more confident that our inference is correct. And then the confidence interval estimate is based on the knowledge that mu equals x bar plus minus a small sampling error. And after we calculate the interval estimate, we can determine how probable is that the population mean will fall within the range of statistical values. So the confidence level is the percentage or decimal that indicates the long-run probability that the results will be correct. And traditionally, researchers have used the 95% confidence level. Whilst there is nothing magical about the 95 confidence level, it's useful to select this confidence level, and this is pretty much 5% tolerance error. That's why they are using this in the examples. Now I'm gonna go back to the previous slide a little bit about Gallup. So we are often inundated with information derived from polls, but polls are built to gauge people's opinion about topics important to their current well-being or to reflect opinions about the society. And we have all kinds of sophisticated sampling techniques that are used to make sure that polls reflect the population of interest. And these polls are usually or often conducted at national levels and reflect the national sentiment of a country. But what about the world? It is possible that an organization might attempt to reflect these sentiments around the globe. So the company that does this and acknowledge leaders in sampling and sampling methodology is the Gallup organization. Their Sample the World program is called Worldview, generate a comprehensive snapshot of opinions of people from across the globe. And they collected worldwide data from over 150 countries on general topics as government, business, education, healthcare, well-being. So their survey methodology is designed to provide a representative sample of 98% of the world's adult population. While it may seem that the sample developed around the world's population may be too generic to provide much benefit, actually Gallup program provides extremely valuable information on poorer and even more rural populations, which often are ignored for more developed countries or population. And in order to accurately reflect this world sentiment and opinions, we must have an accurate sample of the world population. So Gallup's approach, using a sophisticated sampling methodology and comprehensive interview training techniques, provides insight for this global opinions. So this is Gallup. confidence level. Now, how can we calculate the confidence interval? We have some steps. We need to approximate the location. We have the sampling error, estimate the sampling errors, and then we have the sample mean, and we do the calculation. There are some steps here. If you just follow 1, 2, 3, 4, 5 steps, this is how you can calculate the confidence interval levels. Another example that we have here is Target and Walmart shoppers really are different, and there's research companies who are conducting consumer research combining phone interviews and media behavior and mail surveys about different shopping habits and lifestyle, and detailed data about the consumers, and comparing two shoppers here, Target and Walmart. Respondents were asked to identify stores at which they had shopped during the precedent few months, and Target shoppers who shunned Walmart were more likely to shop at more upscale stores, and they are more likely than the average shoppers to visit many different stores. Walmart shoppers who stay away from Target were more likely to shop at discounters stores, and they are more likely to be at least 50 years old. Yeah, so all this data we can collect from these surveys, and we can find really interesting. Sample size. When asked to evaluate a business research project, most people, even those with little research training, begin with asking how big was the sample. And intuitively we know that the larger the sample, the more accurate the research. This in fact is statistically true. Random sampling error varies by sample of different sizes. In statistical terms, increasing the sample size decreases the width of confidence interval at a given confidence level. Obviously, if we collect information from every member of the population, we know the population parameters, so there would be no interval. So when the standard deviation of the population is unknown, a confidence interval is calculated, or we can calculate. And we already mentioned that it's not necessary to take a census of all the elements of the population to conduct an accurate study. The laws of probabilities give investigators sufficient confidence regarding the accuracy of data from the collected sample. And the knowledge of characteristics of sampling distributions help researchers make reasonable, precise estimates in it. So increasing the sample size for sure reduces the sampling errors. Now, factors in determining the sampling size. There are 3 factors are required to specify the sample size. The first, heterogeneity, the variance of the population, then the magnitude of acceptable error, plus minus some amount, and then the confidence level, the one that I said before, 95%. The determination of a sample size heavily depends on the variability within the sample. The variance or heterogeneity of the population is the first necessary bit of information. In statistical terms, this refers to the standard deviation of the population. Only a small sample is required if the population is homogeneous. For the magnitude error or the confidence interval is the second necessary bit of information. And defined in statistical terms as E, the magnitude of error indicates how precise the estimate must be. It indicates a certain precision level. From a managerial perspective, the importance of the decision in terms in profitability will influence the researcher's specification of the range of the error. And then the third factor of concern is the confidence level. Yeah, it's in most business research we will typically use 95% confidence level. And estimating the sample size for questions involving the mean. Determining the actual size from a simple random sample is quite easy. We must follow some steps: estimate the standard deviation of the population, make judgment about the allowable magnitude of errors, and then determining the confidence level. The judgments about the allowable error and the confidence levels are the manager's decision to make. Thus, the only problem in estimating the standard deviation of the population. Ideally, similar studies conducted in the past will give a bias for judging the standard deviation. In practice, researchers who lack prior information may conduct a pilot study to estimate the population parameters so that another larger sample of appropriate sample size may be drawn. And this procedure is called sequential sampling. Because researchers take an initial look at the pilot study results before deciding on a larger sample to provide more precise information. A rule of thumb for estimating the value of the standard deviation is to expect it to be about 1/6 of. For the moment, assume that the standard deviation has been estimated in some preliminary work, and if our concern is to estimate the mean of a particular population, the formula for the sample size is the one that we see here. Z is the standardized value that corresponds of the confidence level. S is the sample standard deviation of estimate of the population standard deviation, and E is the acceptable magnitude of error plus or minus the error factor. Range is 1/2 of the total confidence interval. So thank you so much for this lecture, and see you next time. Thank you.